Hi everyone, I'm Mary with Mary Greeley News. Thank you for joining me. Today is Monday, October 12th, 2020. We have a live view of Old Faithful. Back over here, this hill is the Mallard Lake Resurgent Dome. And it's a bit breezy there, about 12 miles an hour, and people are waiting for Old Faithful to go off. On Friday, a 3-year-old girl was injured there at the park after falling off of the walkway in one of the boardwalks by Grand Prismatic Springs. Evidently, according to news reports, this 3-year-old girl was badly burned and had to be flown out to the burn center there in Idaho. Now, according to reports, it happened near Freight Road, close to the Midway Geyser Basin. Yeah, I don't see any trails here along this parking lot. Let me bring it out for you. And we got Pocket Basin. This is an area of rhyolite, a very thick rhyolite flow. And come down, back down here to this other area where, yeah, I'm not quite sure where she fell and got hurt, but yeah, definitely sending prayers to that little girl and her family. Just terrible. Evidently she's got second-degree burns to the lower half of her body and her back. Well, it looks like the geyser's going off. Like I said, it's fairly windy there, about 12 miles an hour, and it's been cold. There was snow falling yesterday, off and on, throughout the day. But I want to cover what's going on with the monitors there at Yellowstone. Yeah, it looks like a small eruption. Yeah, it was big yesterday and earlier this morning because it was really cold there. But I noticed the last few days at Mary Lake, that's the monitor here on the right, and at West Thumb, that's this monitor here, and then Lake Butte right there. You notice these two monitors, Lake Butte and Mary Lake, yeah, they got magma on the move. Bob Smith, or Robert Smith, the University of Utah, said you don't have to worry unless it gets quiet there at Yellowstone. And it's still been quiet since my last report. But you can see here we got harmonic tremors. Let me try and pull this one over for you. Where are we at? And I'll pull this one over. Yeah, we got the thickening of the lines that I've often talked about. And there's been a few earthquakes. Nothing significant. Let me pull these up for you. Let's see, what time is that? 1900. Which got me to looking into other research about the connection with Mary Lake. Now they know that Mary Lake, when they have earthquakes because of the magma, it moves slower through that area because it's melted more. And what I found was rather disturbing. It's a paper by USGS published in 2007. This shows the rhyolite flows that are in pink. You notice we got Yellowstone Lake here. And this is page 47 of this document that I'll give you. So using Google Earth, here we have Mary Lake, and over here we have Yellowstone Lake, and we have West Thumb Caldera. And I talked about the crack that's at the bottom of Yellowstone Lake. Over here on the right would be Lake Butte. And this crack, there's a dike down below the surface of the earth. They figure it's about 7 inches wide. Where rhyolite intrusion is rising up closer to the area, the surface of the earth, and this is the area of the most recent earthquake swarm. In that paper, it said because of Yellowstone Volcano Observatory deformation monitoring is focused on the Yellowstone caldera, initial uplift associated with the shallow intrusion of basalt magma peripheral to the caldera might not be recognized quickly. This paper, called Preliminary Assessment of Volcanic and Hydrothermal Hazards in Yellowstone National Park and Vicinity, by Robert L. Christensen, Jacob B. Lowenstern, Robert B. Smith, Henry Heisler, Lisa A. Morgan, etc. You should recognize at least two, maybe three of those names. Henry Heisler, Robert Smith or Bob Smith, and Jacob Lowenstern. The emission of magmatic gases to the surface would be a major indicator impending eruptive activity, but might be quite difficult to recognize in the presence of Yellowstone's massive hydrothermal system, which tends to scrub out magnetic gases passing through it. They are not monitoring the gases there. They actually have to send someone out with bottles. They gather the gases from the geothermal areas, which scrubs out the gases to see what's going on. They have no live monitoring like they do at other volcanoes around the world there at Yellowstone. In fact, now that winter's coming, they're taking out many of the monitors in preparation for the snow. Nevertheless, any locally increased emissions of CO2 or H2S should be monitored closely. Any appearance of SO2 presently absent at Yellowstone would be especially indicative that the hydrothermal system was becoming dried out by shallow magmatic intrusion. And then I found this. Volumes of rhyolite erupted in episodes separated by roughly 15,000 to 30,000 years from each of the two linear extensional zones across the Yellowstone caldera, where they intersect the caldera ring fracture system. More than 70,000 years have ensued since the last eruption. To make it a little bit more clear, 25 events between about 170,000 years ago and 72,000 years ago, that was the last eruption, an average interpretive period of about 3,900 years during that time. The average period between eruptions would be 6,800 years, the last of which was 72,000 years ago. That was on page 23 and 24 of this document. Estimating probabilities for one or more long intercaldera rhyolite eruption involves considerable uncertainty, considering that 17 known voluminous lava eruptions and 2 moderately large pyroclastic eruptions are documented, and that additional flows probably are buried within the caldera. The raw probability might be estimated on the basis of approximately 25 events between about 170 and 72,000 years ago. An average interpretive period of about 3,900 years during that time. Alternatively, if it is assumed that the probability of such an eruption has remained uniform from 170,000 to the present, the average period between eruptions would be 6,800 years, the last of which was 72,000 years ago. So we have heard numerous times we are past due for an eruption. And it goes on to say, clearly, however, such calculations are misleading. Well, if it's misleading, why they put it in their own paper? The voluminous eruptions were highly episodic, with numerous events occurring within periods of a few thousand years and longer periods of 12,000 to 38,000 years. Well, they already admitted it's been 72,000 years since the last eruption. Furthermore, general decreased number of eruptions in successive episodes, a doubling of post-eruptive interval compared to the longest previous interruptive intervals, and the fact that the latest of the 5 eruptive episodes was probably a single voluminous event might even suggest that the repeating cycle has ended. They don't know. The paper also said, and I noted that it should be taken of tuff of Bluff Point, the only voluminous ash flow tuff of the Central Plateau member. Its eruption resulted in the formation of the 10-kilometer caldera. That's Little Thumb. So that's about 6 miles, now represented by the West Thumb. The Bluff Point eruption was characterized by ejection of not only pumice, ash, and small lithic fragments, but also vitrophyric lava blocks as large as 1 meter, lava bombs 3 feet across, and possibly involved copious amounts of water from a pre-decressor of Yellowstone Lake. It created a tsunami. That's on page 23 of this document. Based on this example, it is reasonable to suggest that any future voluminous rhyolite eruption within or immediately adjacent to Yellowstone Lake might have the potential to produce an explosive pyroclastic eruption, much smaller in volume than a major caldera-forming event like the Lava Creek Tuff, but nevertheless capable of producing high-speed flows of hot ash, rhyolite debris, and volcanic gas that could affect virtually all of the Yellowstone Plateau area and produce regionally widespread finer ash downwind. Secondary hazards associated with large intercalderal rhyolite eruptions. Now, this is just a rhyolite eruption. This is not a caldera-forming eruption. Could include wildland fires, disturbed drainage, possibility of catastrophic flooding, and they could be especially severe and widespread given their great volume. In particular, if a large volume of lava flow should displace a considerable volume of Yellowstone Lake, overflow could inundate large parts of the Yellowstone River drainage. Other large drainages could be impounded by lava, then released as catastrophic floods, overtopping or undermining the lava dams. Estimating probabilities of one or more large intercalderal rhyolite eruption involves considerable uncertainty, considering that 17 known voluminous lava eruptions and 2 moderately large pyroclastic eruptions are documented, and that additional flows probably are buried within the caldera. The raw probability might be estimated on the basis of approximately 25 events between 170,000 years ago and 72,000 years ago. An average interpretive period of about 3,900 years during that time. Now, once again, this is the area that they're talking about that they know is a threat. There's many areas within this area that they know were formed by hydrothermal eruptions. Duck Lake Formation is one of those hydrothermal eruptions that occurred later. And I talked about up over here, Indian Pond, and this whole area of Fishing Bridge, which is under threat. Yeah, this is the area that would be inundated and clogged up. One of the main roads for people to get out. Subsequent lava extrusion could last for years, meaning the flow could last for years, covering areas as great as 350 to 400 kilometers to thickness of tens or hundreds of meters and volumes of 5 to more than 50 kilometers. Because such voluminous rhyolite lava eruptions have not been observed anywhere in historical times, it is uncertain how long such an event might continue. Available data suggests that highly episodic behavior of past eruptions of this sort, period of a few thousand years, characterized by numerous eruptions being separated by long intervals of about 12 to 38,000 years without eruptions. One statistical measure of eruption probability based on this episodic behavior suggests, on average, recurrence of 20,000 years. Once again, yeah, we're past due. Haven't had an eruption in 72,000 years. The fact that no such eruption has occurred for more than 70,000 years may mean that insufficient eruptible magma remains beneath the Yellowstone caldera to produce another large volume of lava flow, but in 2015, they found out that was not true. You can do a Google search, and here it says there's more magma under Yellowstone than we thought. Yellowstone Supervolcano, much larger than previously thought. Yeah, it could fill up the Grand Canyon 11.5 times. Physics.org had an article showing the magma, mid-crustal sill, weak warm crust, etc. Now, according to this paper, they're not expecting the next eruption to be a small rhyolite flow, but just in case, they do have information about a small flow. There is a small flow near the south entrance to the park. Just as for large rhyolite lava eruptions, initial venting almost certainly would be explosively eject rhyolite pumice. The coarser fragments would fall closer to the vent, but then finer pumice ash would enter the atmosphere and fall down for many kilometers. Structures, power lines, etc. could be damaged by ash loading, especially if eruption were accompanied by heavy rain. The initial explosive eruption could last for a few hours to several weeks and be followed by viscous extrusion of rhyolite lava covering several square kilometers to tens of meters thick. Lava could continue to extrude for many months or even years. The average reoccurrence period of small extra caldera rhyolite eruptions in the Yellowstone Plateau volcano field is about 50,000 years, once again overdue. The probability that the next intercaldera lava flow will have a volume greater than 5 kilometers is about 60%. The probability of a volume greater than 10 kilometers is about 40%. They're expecting a large rhyolite eruption. If a large intercaldera rhyolite eruption were to occur, there would almost certainly be significant premonitory indicators. Now, this is important. Seismic swarms would probably be concentrated in an area of diking. Remember the dike, the rhyolite 7-inch wide dike down there at the bottom of Yellowstone Lake? As magma rose from the magma chamber towards the surface, most seismicity would most likely embrace the entire thickness of the brittle part of the crust above the chamber and might well display a pattern of decreasing focal depths with time. I talked about that too, about the earthquake swarm that happened up here by the fishing bridge area. That happened in 2010. How the earthquakes came in bursts and then paused and burst again and paused and became shallower and shallower. And remember, they put in all these new temporary monitors because of all the increase in activity, and they've been taking them out this winter. It says it might be difficult in the early stages to distinguish typical premonitory seismic deformation or gas emission indicators of a small rhyolite eruption from those of basalt eruption because of more viscous magma uplift and tilting of the ground surface above a zone of intensity swarm. Seismicity might be likely more pronounced for a rhyolite eruption, Also, as such seismic signals are typically associated with subsurface separation of a gas phase from the magma, the time required for any relative deep, long period seismicity that might develop could be longer for a viscous rhyolite magma than for basalt magma. Detecting any such signal might, however, require instrumentation sensitive to a broader frequency range than is currently available at Yellowstone, such as borehole strain meters. So let's take a look at the strain meters, the tilt. We're going to go to Grant, which is on the southeastern side of the West Thumb Caldera. Top is north, X. Lots of dots means lots of shaking. Look at that. Okay, Y is east. last 7 days. Each dot would be an earthquake. And then the last 30 days. Yeah, I've talked about Grant quite a bit in the past. And I've talked about how they're going to have to change the size of the disk. The magma, if you could see it under the ground, is traveling east. But if you look at the ground deformation, yeah, it's rising in the west. Yellowstone is only one of 5 volcanoes where they're monitoring which direction the magma is flowing under the ground. So I suppose the ground deformation, the uplift or the dropping of the ground really wouldn't give them an indication of what direction the magma is flowing under the ground. I don't know how they're monitoring which direction, maybe the strain meters, but the magma is flowing east. And what is east? Yeah, that dike, that 7-inch wide dike that they know for a fact is trying to bring up rhyolite. Now, is there a dike of rhyolite down here where the earthquake swarm is? I don't know. According to the paper, this is the same area of past rhyolite flows. That's the area that's in pink. Let me bring it down a little bit. The 7-day monitor for Yellowstone Lake. Once again, lots of dots means lots of shaking going on. And once again, the magma is flowing east. This monitor is at the bridge where the Yellowstone River flows out. Okay, and this is the 30 days. Okay, top is north. Bottom is east. The 7 days of monitoring at the Norris Geyser Basin. This is a bore. These are all boreholes, deep wells under the ground. Top is north. Bottom is east. Last 7 days. And then the last 30 days. Another monitor, borehole 950 for Norris Junction. Top is north, bottom is east, last week. Yeah, just general uplift. And then the last 30 days. See, most of the activity has been there at Yellowstone Lake, not the Norris Junction area. In the past, yeah, it's been Norris Junction, but right now we're showing a definite increase at the lake. Now, Madison River. This is the last 7 days. Top is north. Bottom is east. And notice this magma is showing a flow towards the east in the last 7 days. Last 30 days. Definitely uplift in both directions. Yeah, look at that. Yeah, my search started with the connection. And I know how the magma moves slower because it's more liquidy there under Mary Lake, and that's the document that I found. Nothing really good about it. There is documentation in there. I believe, 1939, there was 2 deaths attributed to gases there at Yellowstone. It's just been animals and birds and insects and bears and buffaloes. Other than that, but 2 people died after being lowered in a bucket into a 26-foot deep pit near the Yellowstone River and Tower Junction. The man they sent in to rescue the worker was overcome and died from the gases. And then prior to that, in 1883, a woman who was in her basement at Mammoth Hot Springs was overcome by gases. She was found and subsequently rescued. That is on page 34 of this document. Anyways, that's all I have for you right now. Yeah, nothing good. If you have any thoughts or comments or questions, please put it down below. I would advise you to read that document in your own time. Take your time in reading it. Please stay safe, and I will talk to you later. God bless you. Bye.